Write down the binomial expansion of 1 plus x to the power 5. So remember, use Pascal's triangle, okay, and the approach then for expanding a plus b to the power 5. So we'll do that first. Remember then, it's always the first term a to the highest power 5. Okay, plus then, well, the first coefficient was 1, so I didn't bother write it. The second coefficient is 5. A then, reduce the a's, a to the power 4, start increasing the b's. So that'll be b. Plus then 10. A cubed, reduce the a's, increase the b's, b squared, plus then 10 again, a squared, b cubed, plus then 5, a b to the power 4, and then finally then b to the power 5. So then, to expand what they want, we're going to replace a with 1 and b with x, okay? Now, this makes it straightforward. Because a is 1, it'll just become 1 there to the power 5, which of course is 1, isn't it? So I'm just going to write 1. I'm not going to bother to put the power 5 because it's just going to come out to be 1. Here then, again, a is just 1 to the power 4, which is just 1, and then we've got b then after it. Plus then 10 times a cubed, so that's 1. B squared will be x squared. Plus then 10, a squared will be 1, b cubed will be x cubed, and then plus then 5, a b to the power 4 plus then b to the power 5. So just simplifying that then, 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the power 4 plus x to the power 5. Okay, now it says then, hence find the first 4 terms of the expansion 1 plus y squared to the power 5 in ascending powers of y. Now when you see this here, okay, it's no longer a binomial, isn't it? Because there's 3 terms in there, okay? So that can be a problem. But what we can do is think of it as 2 terms, all right? Whereby we group the y plus y squared into sort of one package. So you can put a little bracket around it if you want, okay? Kind of like that. So we've got 1 then plus this term here, and that's a bit like what we've got up here, haven't we? 1 plus x, okay? But here we've got 1 plus this. So in terms of comparing the two, the ones are the same, aren't they? My x, so to speak, then just becomes this sort of package here, okay? So what I can do, I can use this result here, right? But instead of having x, I can substitute this in, right? And think of it as like one term, okay? But obviously it'll be in a bracket. So I'm going to replace x with this here, okay? I'm allowed to do that because it's the same setup to the power 5 and so on. So substitute it in, so 1 plus then 5. So then instead of x, it'll be y plus y squared. Plus then 10, y plus y squared, subbing in there, and of course you've got to square the x, so we've got to square y plus y squared, plus then 10, y plus y squared, okay, cubed. Now, the good thing is I can stop there, okay? I do not need to do that one or that one, right? The reason why, of course, it says it wants the first 4 terms, okay? So when it wants the first 4 terms, the first term will be like a constant. The second term will be a y term. The third term will be a y squared term. And then the fourth term, which is what they want us up to, will be a cube term. Now, I'm going to get all of them from this expansion here. If I included the next one, so I'd have 5 and then bracket to the power 4, the lowest power I get from that bracket would be power 4, okay? And I don't want anything to the power 4. I just want the first 4 terms, which goes up to y cubed. So all I need to do then is expand all of this, okay? But you'll find as well then that actually we won't have to do all the work when it comes to the expansion here. So let's have a look now. So we've got y here, okay? 1 there, sorry. Expand that, so we'll have plus 5y plus 5y squared, okay? Now when I expand this here, okay, I'll have 2 brackets. Let's take our time on it. When I expand this here, I'll have 3 brackets. Now you could use the binomial theorem, couldn't you, to expand it? However, what you'll find is there's not going to be that much work involved, because if I was to actually write 3 brackets there, okay, because it's cubing, the only way I will get a cube term is by one of these terms here, when you expand one of the terms. In fact, when you times the first one by the first term there, that's y squared, and then you times it by that, you get y cubed. That will be the only cube term in there. Every other term will have a higher power. So in fact, I'm only going to get one term from here that I'm interested in. Now, you know, if you don't trust me on that, what you could do, as I said, is expand that using the binomial theorem, and you will only get one y cubed term, and all the rest will be higher powers. Okay, so let's keep going. We've got here, so we've got plus 5y plus 5y squared. Expand this here using FOIL, so 10. So we've got double bracket here, so we've got first will be y squared. Outers, y times y squared is y cubed. Inners, y squared times y is y cubed. Now, do you know what? The last I do not need to do, because y squared times y squared will be y to the power 4, won't it? And I don't need it, okay? I don't need it. I mean, I can write it in if we want, but we don't need it in our final answer. And as I said, then from the final expansion, there's only going to be one y cubed term there, and it will be y cubed. Times it by the 10, will be plus 10y cubed. So multiply out then, we got 1 plus 5y plus 5y squared. 10 times y squared is 10y squared. 10 then, now look at this here, I've got 2y cubed here, haven't I? When you put them together, times 10 is 20y cubed. Don't bother with the last one, because that will be the fifth term, and then plus 10y cubed at the end. Okay, so we get then 1 plus 5y squared plus 10y squared is 15y squared, and then 20y cubed plus 10y cubed is 30y cubed. Challenging question, okay, really challenging question, but by subbing this in for instead of x, okay, you can kind of get there, and you can get the first 4 terms to what they want. And remember, that's the key, isn't it? They only want the first 4 terms. If they wanted all the terms, it would be an absolute nightmare.